So now let's go ahead and do the unsaturated fatty acids. The unsaturated fatty acids are the ones that have double bonds in them. And there are two types. There's the monounsaturated, which means it has just one double bond, and the polyunsaturated, which means that those ones have more than one double bond. Okay, so monounsaturated fatty acid, there's 18 1, so that means it's got 18 carbons, one double bond, and then they'll do a delta 9, which means that the double bond is at carbon number 9. This fatty acid is oleic acid. There's also 16:1 delta 9. What does that mean? 16 carbons, one double bond is at carbon 9, so between carbons 9 and 10. This one is palmitoleic acid. And then there's another one I'd like you guys to know. It's 18:1 delta 9. Oh, but look, you can see that these are identical. What do you think the difference is going to be between this guy and this guy? They both have 18 carbons. They both have one double bond. And they both have the double bond at carbon 9. So what could the difference be? Do you guys remember back in the alkene chapter when at double bonds you could have a cis versus a trans? This one over here is trans. This one is cis. This is called elaidic acid. E-L-A-I-D-I-C. You've heard of trans fats? There you go. That's an example of a trans fat. Anything that's not trans is automatically cis. And the majority of the fatty acids are cis fatty acids. Okay, so let me show you how to draw these. If I'm going to do oleic acid, I could do the carboxylic acid group. So that's carbon 1. And then I'm going to put 7 of these. So 7 CH2s, so 7 plus 1, that's 8. So number 9 comes next. 9 and 10, those are double bonded. And if I'm going to show cis, I just put the 2 hydrogens on the same side of the double bond. That's one way of doing it. And then I will, okay, so this is carbon 9, carbon 10. So now I need 7 more of these, CH2, CH2, CH, 7 of them. And then that'll take me to 17. And then the last one would be CH3. So that's one way of drawing a condensed structure of oleic acid. If I wanted to flip this over and turn it into elaidic acid, all I'd have to do is just show the 2 hydrogens on opposite sides, because remember trans meant opposite, and boom, you've got elaidic acid. Now, if I wanted to do palmitoleic, this is cis. Remember, unless I specify it's trans, they're all automatically cis. This is cis. You just have to shorten it by 2 carbons. So it's 16 carbons instead of 18. So this would be a 5. So CH2, 5 of them, and then a CH3. Now, one way of looking at this also is to do a line drawing. So you could have something like this. I think here's carbon 1, carbon 2, 3, 4, 5, 6, 7, 8, 9. All right, 9. And then you do the double bond. Okay, so this is 9, 10, and then same side, 11, 12, 13, 14, 15, 16, 17, 18. Same side, cis. If I was going to do this as elaidic, be 1, 2, 3, 4, 5, 6, 7, 8, 9, double bond, and then bring it down here because they're opposite. So this becomes 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? Good. Those are the monounsaturated fatty acids. The polyunsaturated fatty acids, there are a couple of them. Actually, I'll give you 3 of them. There's 18:2 means 18 carbons, 2 double bonds, polyunsaturated. So these are polyunsaturated fatty acids. The ones previously were monounsaturated, mono meaning one. So 18:2 delta 9 and 12. What does that mean? It means that the double bond is at 9 and at 12. So we have 2 double bonds. This one is called linoleic acid. Linoleic acid. And then I have another one, 18:3 delta 9, 12, and 15. And that is 18 carbons, 3 double bonds. The double bonds are at carbons 9, 12, and 15. This is linolenic acid. These two fatty acids, linoleic and linolenic, these are called essential fatty acids. For those of you who've had a nutrition class, you may have heard that terminology, essential fatty acids. It doesn't mean that they're important. The term essential just means that your body can't synthesize them. So they're important in the sense that you have to consume them in your diet because your body doesn't know how to make them. Your body's brilliant at making all the other fatty acids, just not these two. So you've got to consume them in your diet. So, you know, this is why you eat salmon or certain vegetable oils. I mean, they're found in a whole bunch of things. All right. The third polyunsaturated fatty acid is 20:4, so 20 carbons, 4 double bonds, and then delta 5, 8, 11, and 14, meaning 20 carbons, 4 double bonds, and the 4 double bonds are found at carbons 5, 8, 11, and 14. All right, so let me draw a few of these. And, oh, sorry, I got to give you the name of this one. This one is arachidonic acid. Remember, arachidic acid was 20 carbons saturated. Arachidonic acid is 20 carbons polyunsaturated. All right. Let's draw linoleic acid. So this one is linoleic acid. And I'm going to do carbon 1, carbon, here we go. I have, remember, I'm going to do at 9 and at 12. So I'm going to have 7 of these CH2s. So 7 plus 1 is 8. So here's my 9. There's cis, unless otherwise mentioned. The only trans I'm going to show you guys is elatic acid. So just assume everything else, all other double bonds are cis. So this is carbon 9 and 10. And then here's carbon 11. And then here's carbon 12 and 13. And then I've got 14, 15, 16, 17. So I need 4 CH2s. So I've got, this is, hold on a second, 12, 13, and then 14, 15, 16, 17, and then 18. Yep, that's right. So I've got 4 of these guys. Okay. All right, this is linoleic acid. Now, have you guys ever heard of omega-3 and omega-6? So the term omega means the first double bond counting from the back over there. Okay, first double bond, what is that? Hopefully nothing I need to worry about. Okay, first double bond counting from the end. If it's 6 carbons from the end, that's called an omega-6. So let's count where the double bond is counting from the end, not from the beginning, because we all remember from organic chemistry, the carboxylic acid is always, always, always carbon number 1. Yes, but the term omega means count from the end. So first double bond that hits counting from the end, you've got 1 carbon plus 4 is 5. This would be carbon 6 counting from the end. So this is omega-6. So linoleic acid is an example of an omega-6 fatty acid. You've heard of fish oils being high in omega-3, omega-6, all of that stuff. There you go. That's what we're talking about. Now, linoleic acid is an omega-3. So let me show you what that is. So here's the carboxylic acid group, and then I've got 7 of these CH2s, and then here's carbon 9, carbon 10, carbon 11, carbon 12, carbon 13, carbon 14, carbon 15 and 16, and then I've got carbon 17 CH2 and then carbon 18 CH3. Sorry, I should have squished it over a little bit, but you get the idea. If you are counting from the end, this is carbon 1, 2, 3, because the first double bond is 3 carbons from the end, this is an omega-3. So linoleic acid is an omega-3. Linoleic acid is an example of an omega-6. So I want you guys to try to draw out arachidonic acid, 20 carbons. The double bonds are at 5, 8, 11, and 14. And tell me, what do you guys think? Is arachidonic an omega-3 or is it an omega-6? Or is it not any of those? Again, play around with it and you should be able to figure that out. Okay, so we're done with the structure of the saturated, monounsaturated, and polyunsaturated. And next we'll start talking about physical properties and melting point, and we'll start putting those fatty acids, hooking them up to glycerol to make triglycerides. Okay? All right.